Hello everyone. Today we're going to be working on example 3-6. And this example says that the beam has a weight of 700 pounds. Determine the shortest cable ABC that can be used to lift it if the maximum force the cable can sustain is 1500 pounds. So we're trying to find the length of ABC to be able to sustain 1500 pounds. So what I'm going to do is I'm going to draw a free body diagram off to the side. So this is our beam, and we know that the beam weighs 700 pounds. So that means that we have 700 pounds acting downwards. So we have a force of 700 already on the beam. Um, we could assume that that is happening right in the middle of the beam. So that means we know that the total beam has a length of 10 feet. So we know that from the force on each side, we have 5 feet. From there, we have the cable, AB and BC. We have cable AB and CB. So we could draw that as forces. So we have force right here, and we have a force right here, and we know that those forces are going to be in tension. And what we're going to do is we're going to try to find the angles right here. As you could see, these angles are also known as theta, given in the image that was provided. So how we're going to try to do it is we're going to try to find the vertical components of these cables. So since they're at an angle, what we're going to do is we're going to try to find that angle right here, so then we can find its vertical component. So what we're going to do is we're going to write out the, we're assuming that upwards is positive, so we know that the sum of the forces in the y direction has to equal 0. So what we have is, okay, I forgot to mention this. So as you guys could see, if we were to draw a line right in the middle, right where that 700 pounds is acting on, you could see that there's a triangle right here that it makes two triangles right here. So what we're going to do is we're trying to find the vertical component of these cables that are in tension. So that means that we're trying to find the opposite side with correspondence to this angle. And we're also trying to find the length of A and B. So we have the opposite side and the hypotenuse side with correspondence to this angle, which is why we could use sine, since sine is opposite over hypotenuse. Which is why what we're going to write is, since we're doing the vertical component, what we're going to do is we're going to write T times sine of theta, since we're writing out our vertical components, plus, and then we have another T times sine of theta, because remember, there are two T's right here. We have our both cables that are in tension. And then we can't forget that we have our 700 pounds, which are acting on it vertically. And as you could see, those 700 pounds are acting downwards, which is why that would be a negative 700 pounds. And we know that the sum of that has to equal 0. So if we were to rewrite this, we have 2t sine theta is equal to 700 pounds. From there, we know that the T max is 1,500 pounds, because in the problem it says that the maximum force the cable can sustain would have to be 1,500 pounds. So that means that the max that it has to sustain is 1,500 pounds, which is why we're going to let T equal to 1,500 pounds. So we have 2 times 1,500 pounds times sine of theta has to equal 700 pounds. From there, we're just going to solve for theta. So sine of theta is equal to 700 pounds times 2 times 1,500. So from there, we have that equal to, so sine of theta is equal to 0.2333, and from there, theta is equal to the sine inverse of that. So that means that theta is equal to 13.5 degrees. So like that, we were able to find theta. And now what we're going to do is we are going to try to find the horizontal now component of it, since now we're going to try to find out what's the shortest amount that this cable could be able to sustain those 1,500 pounds. So what we're going to do is we're going to remember that cosine of theta is adjacent over hypotenuse, right? So that means that cosine of the 13.5 degrees. And then we have, okay, so our adjacent side, we know that our adjacent side of this is the 5 feet. So we have 5 feet. And then what we're trying to do is we're trying to find the hypotenuse side because we're trying to find out. So we know that this is 5 feet. We already know what this was. Now we're trying to find the hypotenuse side because we're trying to see how long that cable has to be. So we're going to call that the length of AB. So from there, what we have, if we solve this for the length of AB, we have 5 feet over cosine of 13.5. That means that the length of AB equals 5.14 feet. But remember, that's just the length for one side of it. So the length of ABC is the same as 2 times the length of A and B, which is 2 times 5.14 feet. So that means that the length of ABC equals 10.28 feet. And just like that, we were able to determine the shortest that the cable could be to be able to hold the maximum force, which is the 1,500 pounds.